Today, we are diving deep into AI engineering, drawing from the incredible work of Chip Huyen. And we're going to answer the one question that seems to be on everyone's mind. AI has been around for decades. So what on earth just happened? And hey, if you were caught off guard, you are in very good company. Even the experts, people who live and breathe this stuff, felt the ground shift under their feet. Chip Huyen says it wasn't just how powerful the models were, but the sheer explosion of what was suddenly possible. And that really is the big mystery, isn't it? The basic ideas behind artificial intelligence, they've been around since the 1950s. So why now? Why did this revolution hit us right now, and not, say, 10 or 20 years ago? What was the missing piece? Well, to find that answer, we've got to look at the explosion itself. You see, it wasn't really one single invention. It was more like a key breakthrough that finally unlocked a door that had been shut for a very, very long time. And if you had to boil it all down to just one single word, that word would be scale. The AI models we have today are just unimaginably bigger than anything that came before. But for years, there was this massive roadblock that stopped anyone from even getting close to this kind of scale. In that roadblock, we call it the data bottleneck. It's pretty simple, really. You can't build a giant model without a giant pile of data to train it on. And for the longest time, getting that data was basically impossible. Okay, so here's why. The old school way of doing things was called supervised learning. And what that meant was for every single piece of data you wanted to feed your AI, whether it's a picture or a sentence, a person, a human being, had to sit there and manually label it first. And the cost was, well, it was insane. Just to create one famous dataset, ImageNet, it cost something like $50,000 just to label 1 million photos. Now, try to imagine scaling that up to label billions of data points. It was way too slow, way too expensive. That was the wall. That was the bottleneck. So it was clear. If we were ever going to get to true scale, researchers had to find a way to smash through that barrier. And the breakthrough, when it came, was this brilliant, almost magical idea called self-supervision. And the difference here is like night and day. With supervised learning, you're paying people tons of money to create labels. But with self-supervised learning, the model is actually clever enough to figure out the labels all by itself, just from the raw data, no humans needed, at all. So how in the world does that actually work? Well, take a look at this example for language. Any sentence, like "I love street food," can automatically become its own training data. You just give the model the first few words, and its only job is to guess the next one. It literally teaches itself over and over and over, using the structure of language itself as the teacher. And the results of this tiny shift in thinking was absolutely massive. All of a sudden, we didn't need these perfect hand-labeled datasets anymore. We could just point our AI models at the vast, messy, chaotic text of the entire internet and just say, "Go learn." The data bottleneck wasn't just solved, it was completely shattered. With that data problem finally out of the way, the race was on. Researchers could finally start building AI models at a scale they had only dreamed of before. And what they discovered was, as the models got bigger, they didn't just get a little smarter, they got exponentially smarter. And that evolution has been unbelievably fast. I mean, we went from these basic language models back in the 50s to the first real large language models like GPT around 2018. And now we have what we call foundation models, these general purpose giants that understand not just text, but images, audio, you name it. But deep down, what are they really doing? It's helpful to think of them as incredibly powerful completion machines. They chop up language into little pieces called tokens, and their entire existence is about one thing: predicting the very next token in a sequence. That's it. An autoregressive model, like the one in ChatGPT, is really just a super advanced guesser of what comes next. And this is where it starts to get really mind-bending. That jump to foundation models meant they became multimodal. This just means the model isn't only looking at words anymore. It can look at an image and read text about that image at the exact same time to predict what comes next. It's learning concepts from different senses, kind of like we do. So this huge shift brings us right up to today. We now have these incredibly powerful pre-built models that pretty much anyone can access. And that has created a whole new field, AI engineering. And this is a fundamental change in how we think about building things with AI. For years, machine learning engineering was all about the slow, hard, expensive process of building a new model from scratch for every single little task. AI engineering? Totally different. It's all about taking these monster foundation models that already exist and just adapting them to build new things on top. Here's the best way to think about it. An AI engineer starts with a foundation model. Think of that as a pre-built super high-performance engine. Then they customize that engine for a very specific job, using things like prompt engineering to give it better instructions, or RAG to give it new documents to read. And the end result is a finished application, the car, that gets built and deployed faster and cheaper than we ever thought possible. And that leaves us with the most exciting question of all. We've moved from a world where only a few massive research labs could build powerful AI to a world where millions of developers can. The barrier to entry has completely collapsed. So now that building with AI is this accessible, what are we all going to create next?